The double-slit experiment is a foundational experiment in quantum mechanics that demonstrates the wave-particle duality of light and matter. Here's a breakdown. The setup. 1. A source, e.g., a light source or an electron gun, emits particles. 2. These particles travel towards a barrier with two parallel slits. 3. Beyond the barrier is a detection screen. What happens classically? Imagine throwing balls. If you were to throw tennis balls at a barrier with two slits, you would expect some balls to pass through each slit and hit the screen behind, forming two distinct bands corresponding to the two slits. What actually happens with light or quantum particles? When light or quantum particles, like electrons, are used. 1. Interference pattern. Instead of two bands, an interference pattern appears on the screen. This pattern consists of alternating bright and dark fringes, which is characteristic of waves interfering with each other. 2. Wave behavior. This interference pattern suggests that the particles are behaving like waves, with the waves from the two slits interfering constructively, creating bright fringes, and destructively, creating dark fringes. The mystery. The truly mind-bending part comes when you try to observe which slit each particle goes through. 1. Observation changes the outcome. If you place a detector at one of the slits to see which one the particle passes through, the interference pattern disappears. Instead, you see two distinct bands, as if the particles were behaving like classical objects. 2. The act of measurement. It seems that the very act of observing the particle's path forces it to choose one slit, and it then behaves like a particle traveling through that single slit. Key implications. Wave-particle duality. The double-slit experiment beautifully illustrates that quantum entities can exhibit both wave-like and particle-like behavior. Which behavior is observed depends on the experimental setup, particularly whether or not an observation is made to determine the path. The role of observation. The experiment raises profound questions about the role of the observer in quantum mechanics. It suggests that observation is not a passive process and can fundamentally affect the system being observed. Quantum superposition. Before measurement, a quantum particle can be thought of as being in a superposition of states, e.g., passing through both slits simultaneously. The act of measurement collapses this superposition into a single definite state. Richard Feynman famously called the double-slit experiment a phenomenon which is impossible to explain in any classical way, and which has in it the heart of quantum mechanics. Do you have any specific aspects of the double-slit experiment you'd like to discuss further?